final talk of the day is one of my favorite categories of talks. It's a talk from a user. So the title is OvS in the Cloud, Testing Our OpenFlow Rule Set to Keep Development Agile. And our speakers are Nicolas, Bouliane, and Blue Thunder Somogyi from DigitalOcean.
Hi, everyone. My name is Nick Bouliane, and I'm here with my colleague Blue, who will give the second half of this presentation. So today we are going to talk about testing our data path, and I think we have a couple of interesting things to share. So I'm a software engineer at DigitalOcean since 2017. My passion for low-level networking started early 2000 when I started hacking on IP tables NetFilter. And today I'm having fun working on OpenVSwitch and also exploring eBPF.
Thank you. My name is Blue Thunder Somogyi. I've been with DO since 2018. I cut my teeth hacking XConk back in the day on Sun Workstation. Should give you a sense of my origin epoch. I spent the better part of a decade at Cisco doing private cloud automation and cloud native networking. Quick shout out to a couple of my favorite technologies. And cheers to Canonical for saving ZFS from the legal dustbin.
So what is DigitalOcean? DigitalOcean is a cloud hosting company founded in 2011, now serving more than 1 million droplets or virtual machine. So as I said, today we are going to talk about testing our data path. But first, what I would like to do is to give you a glimpse of the landscape of how things work and how things are organized. I will also give you an example of things that complexify a bit the testing of our data path, and I will show you a couple of examples of what our data path is composed of. So before starting using OpenVSwitch, it used to be Linux Bridge, EB table, IP tables, all driven by a bunch of Perl scripts. DigitalOcean started using OpenVSwitch in 2014. So using OpenVSwitch certainly helped us unify the logic of our data path and also to express it in a formalized way using OpenFlow. As you can imagine, having all the logic of the data path in one place is a big plus. It's easier to test, easier to reason about, and there are less moving parts. So we are using OpenVSwitch. We are using a lot of OpenVSwitch. Let's see what our network looks like in numbers. So we currently have more than 18,000 hypervisors serving virtual machines. And we have 12 data centers spread across the globe. And just so DigitalOcean did not build all these data centers at the same time. And just as with any software, the way things are built and wired in a data center evolve with time. You start with version 1, and before you finish, you already have ideas for version 2 and then for version 3. But let's see how this can impact our data path. Some older regions use 3 different physical interfaces: ETH0, ETH1, and ETH2 to route the management traffic, the public traffic, and the private traffic. The more recent region use a bound interface that masks the physical interfaces. We will see a bit later how we orchestrate the creation of our flow set. But as you can imagine, if the physical interfaces are different, the flows created will be different too. We've been using Ubuntu Trusty in production for a while, and we are in a process of migrating to Ubuntu Bionic, and this is giving us the opportunity to upgrade OpenVSwitch from 2.7.3 to 2.11. We build our own package to make sure that we have access to a newer version than what Bionic is providing. So we currently run 2 different versions of OpenVSwitch in production, and this is one more variable to take into consideration. Being able to test against different OpenVSwitch version easily is quite important for us. Now let's see the different projects that we have that use OpenFlows. Just as with any software, these projects started small with some basic features in mind. And as they evolve, the corresponding flow needs to evolve too. Keep in mind that many different teams are working on this project and they all need to make change to the datapath logic. So we need to make sure that no one is blocking anyone else and that no flow is conflicting with another one. So we have floating IP. It's public IP address that you can dynamically assign to a droplet. Unfortunately, it was created before the OvS connection tracking integration, so there was no NAT possible. But we have flows that explicitly do the address translation back and forth. Firewall. We allow user to add firewall that will dynamically create new open flows, but there are some limits that we impose. Every firewall can have up to 50 total incoming and outgoing rules. We also only support ICMP, TCP, and UDP. VPC, it's private networking that's adding a second interface for droplets that's only accessible by other droplets. It also provides STT encapsulation between hypervisors. Load balancer as a service, that's a complicated one because they have their own data path. They have their own bare metal Kubernetes installation, and they have their own daemon to orchestrate the creation of their flow set. So that's one more challenge in the creation of a unified testing framework. We have bandwidth billing. So we have flows that we use as counters for the traffic that we are billing. There is the layer 3 gateway project. You will hear more about this project tomorrow, but basically the underlay traffic is now routed instead of being switched. And this is the project that's part of the creation of the datapath validation project that you will hear in the second part of this presentation. We also have internal services. So DHCP that lives behind other 0. We have flows that capture all the DHCP requests and output them via to other 0 so it can be consumed by the DHCP service. We have metadata that lives behind meta 0. So we have flows that capture based on IP destination and TCP port. Amongst other things, metadata is it's an HTTP service that is consumed by Cloud Init for to help the provisioning of the virtual machines. So we don't use an SDN controller. Because we control the MAC and IP addresses a virtual machine will receive, we can immediately install the flows that are needed. We don't have any concept of discovering addresses. Even our DHCP service already know which IP to give based on MAC address. HVFlowD is a service written in Go that lives on every hypervisor. It gets called via gRPC, for example, when a new virtual machine is created or when a new firewall is applied. It is based on the open source library written by DigitalOcean called go-openvswitch. And under the hood, go-openvswitch currently use OvS, VSCTL, and OvS, OFCTL, but we plan to make it speak OpenFlow directly. Now an example on how to express a flow with go-openvswitch. First, we specify the priority and the protocol, and then the fields on which we are matching. So here we are matching a source port and destination port of the DHCP protocol. We have the table in which this flow will live and the action. So basically here we just output the packet out via the other 0 interface. So we've seen the project that compose our data path, or how we orchestrate the flow set that we have, and some example of some configuration that complexify a bit the validation of our that complexify a bit the logic of a datapath. Now let's see how we test all this, and I'll pass it to my colleague.
Thank you, Nick. Yeah, so part 2, we will review the datapath validation framework and some of the design goals and implementation choices that were made during the creation of the framework. Then I'll speak to how we use the framework at DigitalOcean, as well as an example of a validation test. Lastly, I'll review some of the challenges we've encountered and some of the roadmap items for the validation framework. So Nick gave you an overview of why we needed the validation framework, primarily to detect breaking changes in our data path as soon as possible, as well as making sure they don't get promoted to production. So to that end, we wanted to make sure that we had CI/CD integration to catch any breaking changes as soon as possible. Another benefit is the ability to test our data path on live hypervisors, both in staging and production without any production disruption. And another important factor was making sure we were decoupling the framework from OvS details so that it wouldn't become brittle to changes as OvS evolved. The direction of implementation that we went with was to use the go test mechanism. This allowed us to readily integrate it into our CI/CD, which is Concourse. And it also was very low friction for developers because you basically just need the tools you already have installed on your workstation. Lastly, by using the object flag in GoTest, it allows us to create a standalone binary that we can deploy to hypervisors in order to test our data path during rollouts to make sure that everything is as expected. I'll go briefly into the abstraction. As Nick alluded to, we have a go-openvswitch project that DigitalOcean maintains. The data path validation framework builds upon that and creates a framework to specify the packets for the test environment, test scenarios, and the expected actions that the tests are expecting. Here we have an example test where on the left-hand side we have the source packet for the specific scenario, specifying all the details derived from the droplet and hypervisor data. On the right-hand side, we have the listed expected actions that this test should result from. Here it's adding a VLAN and outputting to a specific port. At the bottom of the right-hand side, you can see the validate data path actions function, which what this does is it invokes OF prototrace, gets the actions that the installed data path generate, applies those to a copy of the source packet, and in parallel applies the expected actions to a copy of the source packet and ensures that they are identical. And I can go into the reasons for that approach a little later. So how we use the validation framework at DO. Essentially, we have a makefile wrapper that we can run the entire test suite or a subset of the suite. This is what's done in Concourse as part of our pipeline. Additionally, the make sandbox is very useful while developing tests or debugging tests. It essentially launches a container with an OvS sandbox in which you can run some tests, and then you have access to the environment to continue to debug or run ad hoc tests. And then finally, here's an example of the validate DP binary running on a hypervisor during the rollout of a recent VPC feature being driven by Ansible. In bold, you see the validate DP binary. The dpvalidation.yaml is actually a hypervisor configuration file that's written by Chef to all nodes to really streamline the running of the validation tool. And at the end, you can see an example of running a subset, a wildcarded subset of the test suite. There you go. So some of the challenges that were encountered while creating the framework, the initial intention was to test the actual production HVFlowD binary. However, it's found that there were some baked-in assumptions about interfaces that would have taken some refactoring to solve. Since we didn't have the framework in place, there was a chicken and egg scenario. So the approach we wound up taking was importing the HVFlowD library into the test suite, starting the server internally and using that. Now that the validation framework is in place, hopefully in the future we'll actually be able to test the live binary. That's a future roadmap item. As with most incremental development, how you start fast can sometimes become an impediment down the line. The hypervisor YAML and the JSON droplet configuration files that allowed us to get out of starting blocks very quickly. As the number of test cases and configurations under test grew, there became quite a configuration sprawl. And we have a refactoring of the framework that in work in progress to make that more dynamic. Another set of challenges is mapping the various tests to the configurations for which they're valid, and then making sure that all of those tests are being run. We have another challenge around test coverage. We want to ensure that all the flows that are installed as part of a given configuration are exercised by the test suite. Because we're using OF ProtoTrace right now, it doesn't increment the counters, so we haven't been able to automate that test coverage, but we have some ideas on how to tackle that. Lastly, the reason that the the two copies of the packets are compared was an earlier iteration of the framework actually tried to compare the action output from OF ProtoTrace and the expected actions, but in different versions of OvS, there was some difference in ordering of the output and some no-ops that were causing hiccups. So applying the actions to the actual packet and comparing the results was much more reliable. So an example of some bugs that were found using the framework during the recent VPC feature rollout, or not rollout, the development process, it was discovered that there was an issue between migrated and non-migrated hypervisors. Then the framework actually found that there was a flow priority issue in the fix for that problem. Our colleague Carl said what the whole team was thinking at the time, and Carl and Jacob from DO will also be talking tomorrow about another project that for layer 3 public droplet traffic that heavily leveraged the validation framework as well. So what's next? I mentioned the dynamic configuration, which will get rid of some of the sprawl. It will also allow us to build table-driven tests, which will eliminate a lot of the boilerplate that exists in a number of the tests, as well as having a cleaner mapping between the valid configurations for a given set of tests. As I mentioned, the coverage tracking we haven't been able to do with the flow counters not incrementing, but there's somewhat of a brute force approach we're gonna try and tackle, or try and attempt to extend that feature. Another challenge has been connection tracker traversal, rules that have the connection tracker. OF ProtoTrace has not, the existing test approach hasn't worked with connection tracker based rules, so we're experimenting with live packet generation approach to solve that problem. I've already talked about the HVFlowD binary testing, and one of the midterm goals within DO is to be able to have an A/B or alternate data paths installed such that they can be activated readily, something like A/B testing, but such that they can be activated by um, an ingress flow or a flag flow. The validation framework will be really critical to making sure that those parallel installed data paths will not interfere with each other during the development process. So in summary, the advantages that the existing data path validation framework has given us has provided a lot of confidence and increased our development speed. There's been a number of challenges, but we have solutions in the works for a number of them, and looking forward to implementing the rest of those features.
We have time for questions. So who has a question?
Nick, I might have heard you said you don't have an SDN controller, but you do, right? He's like,
I can. So we don't have an SDN controller in the sense of SDN controller. We don't send packets out of vSwitch. So yeah.
Some people have a very specific idea of what an SDN controller is. I remember being told in a OpenFlow protocol meeting once that what I was proposing was not in the spirit of SDN, very, very seriously. So yeah, people have different opinions. Any other questions? Well, let's thank our speakers one more time.
Thank you, Ben, for being the MC. I know it's a tough job. It's a thankless job. Thank you for doing that. Thank you, everybody, for surviving day one. Awesome. So now for the fun activities, etc. Before we go to the fun thing. For tomorrow morning coming in, you will need the lanyard again. I say that when I left mine in my office accidentally. But so please, when you're coming in, that front door is sort of locked. So just show that to the front lady, and then she'll buzz you in. And then otherwise, you'll have to go through the whole security and another sticker. And we all want to avoid that. So please remember to bring that in. The bar's going to open at 5:30. So we have about 40-ish minutes to mingle and have the hallway track and have more conversations. And then followed by the hors d'oeuvres and dinner, and we'll put all of that out as soon as possible. So we went the extra mile to host a dinner on site so that we could continue the conversations over dinner. I really hope as many people as possible can stay. And in addition to that, the VR roller coaster is here, and hopefully we enjoy that as well. So please, if you don't have to leave, please stick around, have a few drinks with us, experience the VR roller coaster, have dinner with us, and then we reconvene tomorrow. Right, Ben? Right.
So what I've been told is that these tickets in our badge lanyards are for the VR roller coaster and the drinks. The orange one is for the roller coaster. The green ones are for drinks. Is that right?
Yep. Got it. Doesn't matter.
All right. Thanks, everyone. And hope to see you stick around for a while.